All right, so before we get into doing definite integrals and learning some different rules about this, let's do one more as a warm-up here today of finding the definite integral by the limit definition, okay? And then I'll also show you how to check your answer using the calculator. But let's go ahead and take a couple minutes and go ahead and find the definite integral from -1 to 2 of 3x squared plus 2 dx. Alright, before I unfreeze the screen so you guys can see it, what'd you guys get? 15? 15? Okay, we're getting close. Okay, the name of the game on these is just be careful. Okay, that's why on that last quiz when we had the teamwork, I think that was a good opportunity to hopefully catch each other's mistakes there. But let's take a look at the work here. Okay, now we unfreeze the screen. Your b minus a over n was 3 over n. Your f of a plus b minus a over n times I is f of -1 plus 3i over n. I recommend doing this stuff off to the side. Saves you some writing, okay? But also, I want you to get used to writing things properly. If you're going to work through this, one thing I saw in the quizzes, and with multiple choice it's not as big a deal, but free response you can get knocked off for not showing correct work. Alright, if you just say limit as n approaches infinity of the sum, and then you have this, and then you put equals, and then you're just simplifying stuff, and then magically the limit appears again near the end, okay? That's not accurate, okay? You're taking the limit all the way through these steps, okay? So if you're going to write one step equals the next, make sure that you're writing that it's actually equal. Right, the rest of this was really just algebra. Let's step through. I figured out what f of this is. It's a 5 minus 18i over n plus 27i squared over n squared. I plug that in here for the f. And I need to distribute the 3 over n to that. Okay? Now I kind of did two steps at once here because we're getting a little more comfortable with this. I distributed the 3 over n, so I have a 15 over n, I have a minus 54i over n squared, and I have a plus 81i squared over n cubed. I isolated the constant portions of those though, the 15 over n minus 54 over n squared plus 81 over n cubed, and then since this was a constant on the first term, when I take the sum, it's just the constant times n. This middle term has the I in it. The sum of the i's is the n times n plus 1 over 2. And the last term here has the I squared. So I've got the constant 81 over n cubed times the sum of the squares. N times n plus 1 times 2n plus 1 over all over 6. Okay? Now I can take the limit as n approaches infinity. Here, 15n over n goes to 15. I'm just looking at the leading coefficients. Here it would be a negative 54 over the 2. Here it would be 81 times 2 all over 6. 162 over 6. And that all comes out to 15. Alright? Does that make sense? Okay. Now let me show you on the calculator how you would do this, okay? I already have it graphed. You guys know how to graph. I'm just going to show this to you once. If you want to see it multiple times, you can check the video. But let's take a look at... Here's some video. Okay, so here I have the function graphed, and, you know, we could trace around. Alright, if I'm at -1, there's my point, -1, 5. I'm integrating from that point over to the point 2, 14. Okay, So you may have noticed this before, you may have not when we were doing other stuff, but right here above trace we have calculate. So I'm going to hit second calculate, and notice the integral, number 7. All it asks you for is a lower limit, which you can type in. Don't try to just trace over and get close enough. Type in the value, so -1. The upper limit is 2. When I hit enter, notice there's the area. Okay? And notice the area equals 15. Okay? So that's how you could check your answer on the calculator. That's how you could get an answer if you're on a calculator portion of the exam. Okay? Make sure you learn how to use your technology though.
That's interesting.
Okay. So, on to definite integrals. Definite integrals. There are several properties here that I want to look at. First of all, check this one out. This one's fun. We're taking the integral from a to a. That's just a line segment, right? And you guys know from geometry, if we have a line segment, it takes up no area. So the integral, if the interval that you're trying to integrate over starts and ends at the same spot, you haven't enclosed any area there. Okay, so that's 0. Here's what we looked at the end of the last lesson, where if you have, if a function is integrable over the interval that contains a, b, and c, then you can break up the interval into 2 separate ones by taking the integral from a to c and then the integral from c to b and adding those 2 together. Okay?
Would that be better notation if the original one was a to c and you went a to b, b to c?
Maybe. I don't know. I think they just wanted to do it consistent because all the other ones had a to b as the original. All right, and then we have the sum of 2 functions. If we're taking the integral of the sum of 2 functions, we can take the sum of the separate integrals. Here, this one's kind of an interesting one. The integral from a to b is the opposite of the integral from b to a. So think about this, just like acceleration and velocity, when we were doing derivatives, the positive and negative made a difference. Okay? Here in our areas, the positive and negative makes a difference, but also the direction that you're going. If I integrate, typically we're going to be going from left to right, from A to B. But if, for whatever reason, we want to integrate and go in the reverse direction, you can do that. It just ends up being negative. Okay? So there's 2 ways you can get negative areas. One is to be below the x-axis. The other is to be integrating from right to left instead of left to right. Okay?
So if you were below the x-axis and going from b to a, would it be positive?
Yeah.
Okay.
Yeah.
So if you got the answer to the left-hand side of that and the answer was 10, then the answer to the right-hand side would be -10.
Yeah, that's it. And then last we have the constant multiple. If you have a constant times a function, you can pull that constant out of the integral, take the integral, the definite integral, and just multiply your answer by that constant at the end. You will notice here, guys, that with the exception of the top 2 in the rows, okay, or in those columns, these bottom 3 are all nearly identical to the properties we saw for limits and sums. Okay? And that makes sense because what is a definite integral?
A limit.
It's taking the limit of a sum. All right? So these are properties that we actually inherit directly from those, you know, the fact that this is the limit of a sum. Okay? All right. So what we're going to do here is we want to set up a definite integral. We're not going to actually find it using the limit. We're going to set up a definite integral that yields the area of the region. Okay? Now what we're talking about the area of the region is it's the total area enclosed by the function, the zeros, and the x-axis. Now be careful here. This term total area means to treat all area as positive. This is not the same thing as just taking the integral from one end to the other. Because what does that give you?
Some negatives.
Some of if it goes below, some of it's negative. So the answer you actually get is the what area? Do you remember? The net area. Okay? This is not the net area. Okay? So what we have to do here, you'll notice this function x cubed minus 6x squared minus x minus or plus 30, I have graphed over here for us. I'm going to need to do a couple of things with this. For one, you know, we look at where it crosses the x-axis, and this actually crosses at 3 different locations. Okay? And the area that I'm looking for is the area above the x-axis here, and also the area down here. So I need 2 separate definite integrals here. Okay? Now I need to figure out what those values actually are, and if we look at the function, it looks as though one of them is at 5, one's at -2, and one's at 3. Let's kind of confirm that using some synthetic division. It looks like it's 5, -2, and 3. So if I put 5 in here, and I have 1, -6, -1, and 30, I bring down the 1 times 5, -1 times 5. That's going to be -6 times 5 is -30, and that comes out to 0. So yeah, 5 was correct. Remember doing this to test for zeros? You do the synthetic division and it should come out to be 0. Okay.
Could you do it by grouping as well?
We could factor it by grouping, yeah, which may be faster in the long run. If we didn't have the graph, we definitely would. But so let's see, 1, -2, -8. That's going to be a +16. That's going to be +15, -30. That works out. Okay. And then if I do 3 as well, hopefully I'll be getting -30 at the end. So 3, that's 1, 3, -3, -9, -10 times 3 is 30, so that works out as well. Okay? So, those are the 3 values. So the integrals I'm going to be doing, okay, I'm going to be taking the integral from -2 to +3 of f of x dx plus, and then I also have to take the integral from 3 to 5 of f of x dx. But what do I know about that integral? It's going to be negative, so what do I need to do to it?
Make it the opposite.
Make it the opposite, make it positive. So however you choose to do that, I could either make it minus this integral. If you want to get real fancy, you could do the integral from 5 to 3, going backwards. Or I could just do this. Make it absolute value. Okay? So there we have it, and that's going to give us that entire, the total area enclosed in the region. Okay?
And then from there you'd have to do the whole limit, like, definition.
You'd have to do that limit thing twice. Okay? Or just wait till tomorrow when we learn how to do them the easier way. Okay? You guys will like tomorrow. All right, so then we have this one here. We have using the properties of integration. If we know the integral from 0 to 3 is 4 and the integral from 3 to 6 is -1, what's the integral from 0 to 6 going to be?
3.
Yeah, it's going to be 3. We're going to take the integral from 0 to 3 and we're going to add to it the integral from 3 to 6. So of course that's 4 plus a -1 and we get 3. Okay? For part B here, notice we've got the constant -5 times the function. What can we do with that?
Multiply it by 3 to 6. Oh, take it out, but yeah.
Yeah, take the -5 out. Very good. Take that -5 out, and we're going to do the integral from 3 to 6 of f of x dx. So it's -5 times the -1. So we get a +5 for that integral. Okay? So just some basic practice using the properties in order to find some integrals. If we know an integral, we can do some modifications on it and just not have to recalculate a whole integral. Okay, so you've got some practice to do here. 33 to 45, the odd, and 49. Okay, you can see those there. Notice the 33 to 43 are very similar to what we just did. 45, we're using a table. And then 49, we got to think about this a little bit as well. And they give us some things like even and odd functions. If you forget what those are, you might want to look that up. Okay? So